So mesh analysis is applicable only for the planar networks. Okay. Yeah, in Moodle, later I will add, I don't know whether you are added or not, I will add your section, okay, after this class, I will add the section so that you are able to access the material, okay. Okay, so now that mesh analysis is applicable only to the circuits that are planar. The planar circuit is nothing but which can be drawn on a plane with no branches crossing one another. So when you write the KVL equation for the meshes, you will get a linear equation which are to be solved in order to find the unknown current. So you have seen what is the difference between planar and non-planar network. So in order to apply the mesh analysis, the steps are the basic steps. First, you need to identify the number of meshes. You need to assign the mesh current to each mesh in some arbitrary orientation. Then apply KVL around each loop and get the equation in terms of loop currents or mesh currents. Right. Then solve these equations in order to get the unknowns that are nothing but the meshes, mesh currents. So first is identifying the meshes. You know how to identify the meshes. Then you assign the mesh current. Then write the KVL equation. Then solve that linear equation in order to get the mesh currents. Okay. So we'll see the detailed procedure for solving the electrical circuit using mesh current analysis method. So first, what you should make sure that the given network is a planar network. So because you know that the mesh current analysis is not a general one, it can be applied only to the planar networks. Okay. Then all the nodes of the electrical networks are named by letters, either capital or small case, to identify the meshes in the circuit. Okay, this is optional. You can use it or you can skip that. Okay. If there are any practical current sources in the circuit, they are to be converted into a practical voltage source. Suppose if you have a practical current source, what is that practical current source? It is nothing but a current source with a parallel resistance. This needs to be converted into a voltage source with a series resistance in order to simplify the analysis. Okay, if you have a practical current source, it needs to be converted into a practical voltage source. The voltage sources and current sources which are connected in series or parallel are represented by their equivalent voltage source or current source. So you know that if say voltage sources are connected in say series, this need to be converted into a equivalent, that is you need to add up or you need to subtract based on the polarities of the voltage sources which are in series. Similarly, if you have a current sources which exist in parallel, okay, then you need to represent that current sources by a equivalent current source, that is nothing but I1 plus I2, provided both I1 and I2 are having the same polarity, or I1 minus I2 or I2 minus I1 based on the orientation as well as the magnitude of the current I1 and I2. Okay, that we have already seen. Okay, how to represent the equivalent voltage source or current source if the voltage sources are connected in series. Similarly, if the current sources are connected in parallel, how to represent a equivalent current source. So if any resistance or impedance in parallel with the ideal voltage source or in series with the ideal current source can be neglected. Any resistance or impedance in parallel with the ideal voltage source. Any resistance or impedance in parallel with the ideal voltage source or in series with the ideal current source can be neglected. Okay, this we have already discussed. Okay, that is what is that. If you have a resistance or a impedance in case of AC network, which is in parallel with the ideal voltage source, then this you can neglect because this becomes redundant, because you know that the voltage across this resistance is nothing but this voltage source value itself. Okay, and if there exists a resistance or a impedance in series with a current source, this resistance also becomes redundant, that you can neglect when you are going for the analysis, because you know that the current flowing through that resistance is same as that of the current source value. So you can neglect the redundant resistances, okay, or impedances, that is the resistance or an impedance which is in parallel with the ideal voltage source, and a resistance or an or impedance in series with a current source can be neglected for before doing the analysis. Okay? Or for the analysis, you need not consider those resistances, okay, which are redundant. A mesh currents are assumed arbitrarily in clockwise or anti-clockwise direction. Okay, but normally what we are considering is that we are going to consider the convention as we are considering all the currents flowing in the clockwise direction. The equation for the meshes are written using general mesh analysis equation. Okay, that is by applying KVL to each mesh. Okay, we write the equation for each mesh. This mesh equation need to be solved by making use of Cramer's rule or any other method. Okay, that is, you can go for back substitution, or the linear equation, simultaneous equation, you can directly solve it. Okay, so you can solve those linear equations in order to find the unknowns. Okay, for the first problem, I will do the Cramer's rule also. Okay. Then for the remaining problem, directly you can substitute those values in the simultaneous equation using your equation in that calculator. Then you can find the solution. Okay, but you should know how to how will you get those values by solving those equations. Okay. When you have a AC circuits, you have to go for Cramer's rule. See, in the materials which I have uploaded the circuits related to the AC source also. But after completing this mesh and node analysis, I will do the problems related to the AC sources. Okay. Together for all the four methods, I will do that the numericals related to the AC sources after completing this mesh and node analysis. Okay. Once you know the mesh currents, once the mesh currents are calculated, the branch current can also be calculated. Okay. So once you know what are the mesh currents, then you can calculate what are the branch currents or what are the required currents they have asked. Okay. Now, take down one example. Let us find out the branch currents using mesh analysis. So take down this problem. For the circuit shown, find the branch currents using mesh analysis. Find the branch currents using mesh analysis. See, when you are going to apply the mesh analysis, you are going to find the mesh currents. Okay. So in this particular circuit, I1 and I2 are nothing but the mesh currents. What they have asked you to find is nothing but the branch currents. Branch currents are nothing but they have given here I1, I2 and I3 you need to find out. Okay, I1, I2 and I3 are the branch currents. I1 and I2 are the mesh currents. Okay. So here, what you are doing is that you are finding the mesh currents. Once the mesh current is known, you are going to find out what are the branch currents. Okay. So here, looking at this, you can find out that once you determine I1 and I2, you can see that the branch current I1, that is capital I1, is same as that of the mesh current I1. This I1 is same as that of I1, right? What about I2? I2 is same as that of the mesh current I2. What about this I3? I3 is flowing in this particular branch. Okay, I3 is the branch current which is flowing in this particular branch. Okay, which consists of 10 ohm resistor and 10 volt voltage source. Okay, that branch is common to both the meshes. So what is the current I3? I3 is nothing but I1 minus I2. Okay. So here I1, I2, I3 are the branch current. I1 and I2 are the mesh currents. Okay. And the branch currents in terms of mesh currents are I1 is same as that of the mesh current 1. I2 is same as that of the mesh current 2, and I3, since I3 is flowing in a branch which is common to mesh 1 and mesh 2, it is I1 minus I2. Why it is I1 minus I2? I3 is flowing in this downward direction. The current I1 is also flowing in the same direction. But whereas I2 is flowing in the upward direction, so this should be, I2 should be subtracted from I1. Okay. See, if you have any doubts, you make it clear. Okay. So because this mesh analysis and node analysis are the basic concepts, okay, you should be very thorough with those concepts. Okay. Now let us write the KVL equation. Okay. See, you need to find out, even though you need to find out the branch current, for the time being, you forget about that I1, I2, I3, because you are going to find the mesh currents. Okay, or when you are writing the KVL equation, you write the equation in terms of mesh currents itself. Once the mesh currents are obtained, by making this, using this relation, you find the branch currents. Okay, now let us apply KVL to mesh 1. Okay. Apply KVL to mesh 1. Okay. Now, here when you apply KVL to mesh 1, see whatever convention I am going to consider this, I have already told you, minus 2 plus, I will be considering it as positive. Okay. Plus 2 minus is negative. That is the second sign I am going to consider. Okay. So it is minus 2 plus, it is 15. In the resistor, the current is flowing from higher to lower potential. So this n will be minus, right? So it is minus 5I1 minus, okay, 10 into I1 minus I2. Sorry, this is small I1. Okay, this is a mesh current. 15 minus 5I1 minus 10 into I1 minus I2 plus 2 minus 10 equal to 0. Okay. Or you can simplify it and write you can simplify it and write, okay. This is 5I1 minus 10I1 plus 10I2 minus 10 equal to 0. Okay. Or 5I1 minus 10I1, it is minus 5I1 minus 10I1, it is 15 minus 15I1. Okay. So minus 15I1 plus 10I2. Okay, 15 minus 10, that is 5. Okay, so I will bring it to the other side, so it will become minus 1. This is equation 1. Okay, minus, or you can write it as, this as 15I1 minus 10I2 equal to 5. 15I1 minus 10I2 equal to 5. Right. Multiply the entire equation by minus 1. Okay. Next, you write a KVL equation for the second mesh. Okay. So apply KVL to mesh 2. Okay. This is the mesh 2. Minus to plus, it is 10. Here, plus to minus 10 into minus 10 into I2 minus I1. See, I am considering the KVL equation for the mesh 2. So, I am moving according to the mesh current I2. So, here minus to plus, plus 10 more, plus to minus 10 into I2 minus I1, okay, minus 6 I2, okay. Forget about that I1, I2, I3, okay, that are the branch currents which are given, okay. Minus 4 I2 equal to 0, or 10 minus 10 I2 plus 10 I1 minus 6 I2 minus 4 I2 equal to 0, okay, or 10 I1, okay, minus 10 minus 6 minus 4, that is minus 20 I2 plus 10 equal to 0, or equal to minus 10. Okay, I have taken it to the other side. These are the two equations. Equation 1 and equation 2. Okay, or you can write this as minus 10 I1 plus 20 I2 equal to 10. Okay, now you have two equations. Okay, equation 1 and 2. The first equation is what? It is, I'll write it here, minus 15 I1 plus 10 I2 equal to minus 5 is the equation 1, minus 10 I1 plus 20 I2 equal to 10. 10 is the equation 2. Can you solve this and tell me what are the values of I1 and I2? You solve the linear equation. Okay, in your calc you can use that equation. Okay, the number of variables is 2. Substitute the coefficients along with the sign, then find out the values of I1 and I2. Quickly tell me the answer. It is 1 and 1. Okay. So here I1 is, you will get it as 1 amps. I2 you will get it as 1 amps. Okay. So what you need to find out is nothing but I1, I2, I3. Okay. What is I1? I1 is nothing but the mesh current I1 is nothing but 1 amps. I2 is also 1 amps. I3 is what? It is I1 minus I2. That is nothing but 1 minus 1. It is 0. That means there is no current flowing in this particular bar. Okay. I3. Okay. It is nothing but I1 minus I2 is 0. Now, do you know how to use Cramer's rule? Do you know how to apply Cramer's rule to solve the equation? Cramer's rule. Yes or no? How to apply Cramer's rule? You don't know? Matrix method to solve the simultaneous equation. You have not gone through that. Huh? Yeah, have you? I just want to. Have you studied or you forgot? You have studied. Huh? Yeah, you have studied. Okay, I will just take the attendance. Yeah, okay. So we'll see how to write, apply Kramer's rule for this. Okay. See, when it is AC networks, you have to go for Kramer's rule itself. So in Kramer's rule, what you have to do is that when before applying Kramer's rule, you need to write this linear equation in the form of a matrix. Okay, that is 15. That is the coefficient of I1. This is 10, coefficient of I2. Minus 10. This is 20. This is nothing but I1, I2. Okay. Minus 5. These are the right hand side coefficients. Okay. This is of the form Ax equal to B. Okay. Now, when you need to find I1, okay, when you have to find out I1, it is nothing but delta 1 divided by delta. Okay. So, what is delta 1? It is nothing but the determinant which is obtained by replacing the first column by the right hand side coefficient. Okay. See, first I will write what is delta. Delta is nothing but the determinant. This determinant of this matrix, that is minus 15, 10, minus 10, 20. Okay, determinant. This determinant. What is delta 1? In this delta, you replace the first column by the right hand side coefficient. Okay, that is minus 5 and 10. The second column you write as it is. Okay. Now this determinant, if you solve delta 1 by delta, it will give you what is the value of I1. Okay. So can you tell me what is delta 1? It is minus 20 into 5. Okay. Minus 100 minus 10 into 10, that is minus 100. Okay. This is 50 into 20. How much it is? Minus 300. Minus into minus, it is plus 100. Right. Okay. Minus 200 divided by minus 200, it is 1 amps. Did you get it? Did you get how to find out I1 using Kramer's rule? See, this determinant is the determinant of A matrix, delta. Okay, delta 1 is nothing but in the determinant of delta, you replace the first column by the right hand side coefficient. What is delta 2? I2, how will you find it? Is delta 2 by delta. You have to replace the second column by the right in the determinant of delta. If you replace the second column by the right hand side coefficient, you will get the delta 2. Delta 2 by delta will give you I1. Did you get how to use this? Okay. Yeah. Now, what is I2? I2 is nothing but, okay, I2 is nothing but delta 2 by delta. Okay. What is delta 2? In the determinant of delta, you replace the second column, not in delta 1. In the determinant of delta, you replace the second column by right hand side coefficient. Okay. This delta value we have already calculated. That is, if you want, you can write, or you can directly write it as minus 200, because we have already calculated that one. Okay. Now it is minus 150. Okay. Minus 50. Right. Minus 150 minus 10 into minus 10 into minus 5 is plus 50. Okay, so it is overall it is minus 50 divided by minus 200. Minus 200 by minus 200, it is 1x. Okay. I hope it is clear. Any doubts here using the Cramer's rule? Any doubts? Say suppose if you have three variables, that is three equations you will have. Okay. You will have three equations, three linear equation. What is I1? I1 is nothing but delta 1 by delta. I2 is delta 2 by delta. I3 is delta 3 by delta. When you have three equations, you will have 3 cross 3 matrix. A matrix is nothing but 3 cross 3 matrix there. Okay. So, if you have 3 cross 3 matrix, okay. So, find out the determinant that will give you delta. Delta 1 by delta will give you I1. I2 is delta 2 by delta. That is, replace the first column with the right hand side coefficient and find out the determinant that will give you delta 1. Delta 2, replacing the second column with the right hand side coefficient. Similarly, in order to find I3, you have to replace the third column by the right hand side coefficient. Okay, and find the determinant. Delta 3 by delta will give you what is the value of I3. Okay. I hope it is clear. Yes or no? Cramer's rule, application of Cramer's rule. Okay. So take the next problem. Using mesh analysis, find the currents in various branches of the circuit. Using mesh analysis, find the currents in various branches of the circuit. Okay, that voltage source value is 42 volt. Okay. First, what you do is that the mesh current is given and the orientation is also given. Try to apply KVL and write the equation for mesh 1 and mesh 2. Write the equation for mesh 1 and mesh 2. So the first equation is for mesh 1. Okay. If you have any doubts, you can ask. Okay, it is minus 2 plus 42 minus 8 I1. Okay, minus 4 into I1 minus I2 equal to 0. Okay. For mesh 2, it is minus 4 I2 minus I1. Okay. This current is flowing in this direction. Plus 2 minus 4 I2 minus I1 minus 6 I2 minus 2 plus 10 equal to 0. Okay. Or 8 minus 12 I1. Okay, the first equation is minus 12 I1 if we simplify it, plus 4 I2 equal to minus 42 is the first equation. Okay. 12I1 plus 4I2 minus 42 equal to minus 42 is the first equation. Here minus 10I2, 4I1, okay, minus 10I2 equal to minus 10 is the second equation. So can you tell me what are the values of I1 and I2? Anyone have doubts in writing the equation? So I1 is nothing but 4.42. Yeah, right. I2 is nothing but 2.77.
Ma'am,
Yeah.
after obtaining the equation, how to find out I1 and I2?
See, in your calculator, you go to
Yes, ma'am.
this one, equation.
Yes.
Did you get that equation?
Yes, ma'am. Yes.
Yeah, in that number of unknowns will be there, right?
Yes, ma'am.
Number of unknowns, how many unknowns in this case? It is 2,
Two.
right?
Yeah.
Yeah,
Yes.
2. Okay, now there you will get A1, right?
Yes, ma'am.
A1, you enter it as minus 12,
Okay. Okay.
press enter,
Got
then
it.
B1
Yes.
is 4, C1 is minus 42. Like
Yes.
that you, okay,
Yes.
keep
Got
on
it.
and, okay, you will get the value.
Yes.
Did you get it? Yeah, it is. See here, 4 minus 4 into I1 minus I2 because see the current I have assumed it in this direction. This is I2, right? So this is at higher potential, this is at lower potential. So this 4 ohm, okay, I am moving according to the orientation of I2. So plus to minus 4. Which current is flowing according to this orientation, this polarity? It is I2, right? Okay, whereas I1 is flowing in the opposite direction. So it is minus 4 I2 minus I1. Did you get it, Karthik? Okay. So when you consider the first mesh, it is minus 4 into I1 minus I2 because you are moving in the orientation of, see, when you consider the first mesh, it is the current I1 is flowing from higher potential to lower potential. You are moving according to the orientation of I1. So it is plus to minus 4 into I1 minus I2. So when you come to this loop, it will be you are moving according to the orientation of I2. With respect to I2, you are writing the equation. So it is minus 4 into I2 minus I1. Have all of you got the answer? So what they have asked is that you need to find out the branch currents. Okay. So what is branch here? It is one branch is D. Okay, this is one branch. Okay, D, A, B, C. Current through D, A, B, C. Okay, this branch is nothing but what? I1, right? It is I1. I1 is how much you got? I1 is nothing but 4.42 amps. Okay. Current through this branch, okay, this particular branch D, A, B, C is nothing but same as that of the mesh current I1. What about the current through C, E, F, D? Current through C, E, F, D is how much? Same as that of I2. I2, how much did you get? It is 2.77 amps. Okay, 2.77 amps. What is the current through this CD? CD is nothing but this branch is common to both the meshes, so it is I1 minus I2. Okay. That is nothing but 1.65 amps. Did you get the answer? Yes, any doubts? Did you get it? I1 is 4.42, I2 is 2.77, and the current in the branch CD is nothing but 1.65. Okay, take down the next problem. Take down the next problem. Find the currents. Find the mesh currents I1, I2, I3. Here you need to find out the mesh currents. Okay, so this is I1, I2, and I3. Find the mesh currents I1, I2, I3. Here you have three meshes. Okay. The current orientation is given. You write the KVL equation for mesh 1, mesh 2 and mesh 3 so that you will get three simultaneous equations. Solve those three equations in order to get the values of I1, I2, I3. Copy the problem. Copy the circle. Okay, try to write the equation. See, you are writing, when you write the equation for first mesh, it is minus 2 plus 7. Okay. See, through this branch CD, the current flowing is nothing but I1 and I2. So it is minus 1 into I1 minus I2. Got it? See, you are writing the equation for this particular mesh. So here you have voltage source, this resistor, this voltage source, and here one more resistor. Okay. So 7 minus, because the I1 is flowing from plus to minus here also plus to minus, whereas I2 is flowing in the opposite direction as that of the current I1. So 7 minus 1 into I1 minus I2 plus to minus 6 volt. Here plus to minus 2 into I1 minus I3 equal to 0. Is any doubts in writing the first equation? It is minus 2 plus plus 7 plus 2 minus minus 1 into I1 minus I2 plus 2 minus minus 6 plus 2 minus minus 2 into I1 minus I3 equal to 0. Because through this resistor the two currents are flowing, that is nothing but I1 and I3. So you can simplify it and write I1 plus I2 minus 6 minus 2I1 plus 2I3 equal to 0. Okay, so 7 minus 6, it is 1, minus I1 minus 2I1, okay, it is minus 3I1. So you can write it as minus 3I1 plus I2 plus 2I3, okay, equal to minus 1. That is 7 minus 6 is 1. When I take it to the right hand side, it will become minus 1. Similarly, write the second and third equation. Is any doubts in writing the first equation? Write the second equation, that is, see, now you are moving in the direction of I2. Here you have three resistors, so you need to write the voltage drop across those three resistors. Okay, so you can start with 1 ohm. Okay, minus 1 into I2 minus I1, because you are moving in the direction of I2. Okay, minus 2 into I2, because through this resistor only current I2 is flowing, minus 3 into I2 minus I3, because through this 3 ohm I2 and I3 are flowing. So minus 3 into I2 minus I3 equal to 0. Okay. Or minus I2 plus I1 minus 2I2 minus 3I2 plus 3I3 equal to 0. Okay. Minus 6I2 I1 minus 6I2 plus 3I3 equal to 0. This is the second equation. Okay, the third equation is, when you are writing it, minus 2 into I3 minus I1 minus 2 plus, that is plus 6 plus 2 minus minus 3 into I3 minus I1 minus I3 equal to 0. Okay. When you simplify it, minus 2I2 plus minus 2I3 plus 2I1 plus 6 minus 3I3 plus 3I1 minus I3 equal to 0. Okay. Or 2I1 plus this is 3 into I3 minus I2, right? Minus 3 into I3 minus I2. Okay. So minus 2 into I, this is minus 2 into I3 minus I1 minus 2 plus plus 6 minus 3 into I3, this is I2. Okay. 3 into I3 minus I2 minus this, through this it is I3. Okay, minus 1 into I3 equal to 0. Minus 2I3, 2I1, this is equal to 0. 2I1, okay, plus 3I2 2 minus 6I3 equal to minus 6 is the third equation. So what are the values of I1, I2 and I3? I1 is nothing but 3 amps, I2 is 2 amps, I3 is 3 amps. Did you get these values? See, in 2 ohm resistor, it is not, see, don't get confused. See, you are writing the equation considering the orientation of I3. So this is plus to minus is for this orientation. You have assumed the current in this first mesh in the clockwise direction. Through this 2 ohm, it is going from plus to minus. When you are writing the equation for this particular mesh, this end will be plus, this end will be negative. Because you are writing the equation with respect to this particular current. So when you are assuming this orientation for I3, okay, here through this 2 ohm, it flows from higher potential to lower potential. So this end will be plus, this end will be negative. Here you are writing with respect to current I1, okay. This polarity with respect to current I1, okay, I1 flows like this, plus to minus here, whereas I3 through this 2 ohm flows in the opposite direction. Yes, Harshavardhan, is it clear? See, based on the orientation of the current which you are assuming in the particular mesh, you have to write it as higher potential to lower potential. According to that, you are going to write the condition. Others, any doubts? Now all of you got that answer, 3, 2, 3. Okay, take down the next problem. Take down the next problem. Find the current Ix using mesh analysis. Find the current Ix using mesh analysis. Find the current Ix using mesh analysis.